All right, here we go. Very last lesson for this chapter, for chapter 3. So this is 3-7, day 2. And in this lesson, we're going to take and combine a lot of what we've been doing in this chapter to look at some different things as far as how to come up with an equation in both factored form and standard form, using the end behavior and the degree of the polynomials to figure out some different things with that. So we're going to be, like I said, using a lot of the tools that you've been learning from previous sections. So I hope that you haven't forgotten a lot of that, because it's going to come together in this lesson. All right, so we're going to skip doing a warm-up again. We're going to jump right into things. So here we're going to look at how to identify a transformation based on just the graph. Okay, so we ended the last video where we gave you the equation, and you needed to identify the different transformations that were happening to describe what the graph would look like. Well, now we can see what the graph looks like, so we're going to work our way backwards to come up with what would the original function have been. All right, so here they tell us that the given graph is a transformation of the parent cubic function or parent quartic function. We've got to figure out which one. How can you determine the equation of the graph? Okay, so they're telling us it's either a quartic or a cubic. So a cubic means that the degree would be 3. Quartic means that the degree is 4. So hopefully you can identify, based on what we did earlier in this chapter, that this would not be a quartic. So if it's quartic, if it's even, both ends of the graph would have to be going the same direction. But since the graphs are going in opposite directions, or the two ends, the end behavior of the graph are going in opposite directions, this must be an odd power function. So that leaves us with the only option of this being a cubic, because of the only two choices they gave us. So it's definitely based on the graph y equals x cubed. So now we want to come up with an equation for the line that they have graphed for us. And so we want to look to see what kind of transformations or translations, what kind of things have happened to the graph. All right, so if it was just y equals x cubed, it would have started at the origin. What if that little turning point would have happened at the coordinate 0, 0? Well, now that turning point is now at the point -3, -1, which means it's moved to the left 3 units and down 1 unit. Well, if it's moved to the left 3 units, oh, and by the way, actually we can take a step back. It doesn't matter what order we do these in as far as the negative or the plus, all that kind of stuff. But what they did is they identified the fact that it's been flipped over the x-axis, or it's been so it's going to start out with a negative, okay, because it's been flipped. Or you could also look at it as, since the leading coefficient is negative, the right side of the graph, since the right side of the graph is going down, the leading coefficient would have to be negative. Okay, so remember, the direction of the right side of the graph will tell you if the leading coefficient is positive or negative. Or you could look at the graph and see it's flipped over the x-axis. Either way, it's negative in front. All right, so we would have negative x cubed is what they're saying there in blue. But then as far as where that turning point has happened, or has moved to, it's at -3, -1, which means it would be, in parentheses, x plus 3. Okay, it's x plus 3 because it went to the left 3 units. And then it's cubed, so we'd have parentheses cubed. And then it's gone down 1 unit, so outside the parentheses we'd have -1. So that would give you the equation of the function. So the equation of the function would be negative quantity x plus 3 cubed minus 1. Pretty simple. Let's look at this one. So this one, it says the given graph is a transformation of the parent cubic function or parent quartic function. How can you determine the equation of the graph? So again, we're trying to find what the equation of the graph would be. So we could see that both ends of the graph are going the same direction. So it has to be an even power function, which again, they're giving us the choices of a cubic or a quartic. So the only option is it has to be a quartic. So it has to be in the form y equals x to the 4th power. Now, the right side of the graph is going down. So if it's the end behavior on the right side is going down, that means that the leading coefficient has to be negative. So it would be y equals negative x to the 4th. So then we can look to see, well, where's the vertex? The vertex looks like it's at the coordinate where x is 1 and y is 5. So it's moved to the right 1 unit and up 5 units. So if it's moved to the right 1 unit, inside of parentheses here, we have x minus 1. So it'd be x minus 1 in parentheses to the 4th power. It's moved up 5 units, so we'd have plus 5. And then, like I said, don't forget about the negative in front. So our equation for this would be y equals negative quantity x minus 1 to the 4th power plus 5. really rather simple. It's really nice to end this chapter on a simple note, since some of the stuff that we've been doing has been kind of tricky. So I want you guys to try this now for these two graphs. I want you to figure out whether it's cubic or quartic, and then based on that, figure out what the equation would be looking at the translations that have happened. Okay, so pause the video and hit play when you're ready to check to see if you've done these two correctly. How did you do? Let's see. So the first one there, that would definitely be a cubic. Okay, the right side of the graph is going down, so it's going to be negative out in front. The turning point, or where it's twisted at, however you want to look at it, that's moved to the right 2 units and up 4 units. So we would have in parentheses x minus 2 quantity cubed, and then it moved up 4, so plus 4. The other one is obviously the quartic one then. It's even. The right side of the graph is going up, so the leading coefficient would be positive. The vertex has been moved to the left 1 unit and down 3 units. So if it's moved to the left 1 unit, it would be x plus 1. So it would be x plus 1 quantity to the 4th power. Then it moved down 3 units, so minus 3. So hopefully you got both of those correct. All right, let's end all this by looking at a story problem. So here it says the volume of a box in cubic yards is given by the function v of x equals x cubed. The post office lists permissible shipping volumes in cubic feet. Okay, so this is in cubic yards. That equation is for cubic yards. We want to basically look at that equation. Okay, that's in cubic yards. What would it be in cubic feet? So first off, there's 3 feet in 1 yard. So we're going to restart by replacing x with 3x and then simplify it. So if I replace x with 3x, so it's really important to use parentheses here. So we're not just cubing the x, we're cubing the 3 too, because we're replacing x with 3x. So 3x, when you cube it, becomes 27x cubed. So now we have our formula that would give us the volume of the box in cubic feet. So it says in part B there, terranium is in the shape of a rectangular prism. The volume of the tank is given by the equation. So we have there in the right there, we have the length, the width, and the height as being x, 2x, and x plus 5. So if you were to multiply those together, x times 2x would be 2x squared, and then we'd multiply 2x squared times x plus 5 and get 2x cubed plus 10x squared. So they did all that in one step. If we were doing this on our own, we would do that in 2 steps, where we take the x times the 2x first, take that answer times the x plus 5. Please do not think it is this. Common mistake that I'll see people make is they'll just think, oh, we're distributing here. So we're going to take x times the 2x and x times the x plus 5. Wrong. Okay, so what I tell students is if I had 2 times 3 times 4, we would not take 2 times 3 and then 2 times 4. Okay, we would take 2 times 3 and get 6, and then take 6 times 4 to get 24. So we're going to apply the same concept here by just multiplying these two together first. X times 2x is 2x squared, and then multiplying that times what's in parentheses. So that we would have to distribute because you have 2 terms in parentheses there. And that's how you get the 2x cubed plus 10x squared. All right, so we have that equation, 2x cubed plus 10x squared. Now it says the manufacturer wants to compare the volume of this tank with one that has a width 2 inches shorter, but maintains the relationship between the width and the other dimensions. So we're going to write a new function. So basically, we're going to replace x now instead of with, like in the previous one, we just replaced x with 3x. Here, we're reducing it by 2 inches. We're going to have x minus 2. So every time we see an x with the original dimensions, the x, the 2x, and the x plus 5, we're going to replace each of those original x's with x minus 2. So we would have this piece here. Let me get my highlighter. So we would have this piece here that we would have to simplify. So what we're going to do now is we're going to multiply some of those. Well, let's simplify some of those pieces together. So this 2x minus 2 you can distribute to have 2x minus 4. The x minus 2 plus 5, that simplifies to be x plus 3. All right, so the next thing we're going to do is we are going to multiply these together to get, so again, we have to do this in steps. Now you can do it in any order. Okay, like that 2 times 3 times 4 problem I had earlier, I could have taken 2 times 3 and gotten 6, 6 times 4 and I could have gotten 24. Or with the 2 times 3 times 4, I could have taken the 3 times 4, the last 2 numbers first, and gotten 12, and then multiplied that by 2 and gotten 24. So it doesn't matter what order you multiply in. So I want to make sure that's clear. So here's what they're doing. They're multiplying the x minus 2 times 2x plus 4. They're multiplying that first. And when they did that, they got 2x squared minus 8x plus 8. So you could FOIL that. You can use the box method. Either way, you get 2x squared minus 8x plus 8. Now, the last step, this is where I would definitely use the box method. And to show you how they did that real quickly here, what they did is, or an easy way to do that would be to draw your box. Now this would be a 2 by 3 grid because we have 3 terms times 2 terms. And we would put the 2x squared minus 8x plus 8 on top and the x plus 3 on the side. We'd multiply all those together, combine like terms, and that's how you get the 2x cubed minus 2x squared minus 6x plus 24. So that would be the equation for the volume. Okay, so that's how you would do that. All right, I want you guys to try one on your own. Okay, so there's 2 parts to this one. Here it says the volume of a cube in cubic feet is given by that function v of x equals x cubed. We want to write a function for the volume of the cube with cubic inches as the units. Okay, so in the previous problem we wanted to write it as cubic feet, and so there was 3 feet in a yard, so we replaced x with 3x. So here we want to convert this to be an equation that would give us our volume in cubic inches when it's in feet. So you need to figure out how many inches are in a foot and use that to figure out what to replace x with. And then the next one, I want you to do the next one too. That's where we have x times x minus 1 is your volume of a box. And we want to make a box that's 1 foot longer in every dimension. So we're going to replace all those x's, the x minus 1. I want not the x cubed minus x squared. That's going to be too difficult. But we're going to take x times x minus 1. We're going to replace each of those 3 x's with x plus 1. So we're going to try to come up with a formula that would give us the volume if it was 1 foot longer in every dimension. So I want you to try both parts A and B. So pause the video and hit play when you're ready to check to see if you've done both of those correctly. All right, let's see how we did. The first one would have been a little easier. So hopefully you recognize that there's 12 inches in a foot. So we're going to replace x with 12x. And so if I do that, we would cube the 12 and the x. When you cube 12, you'll need a calculator for that. 12 cubed is 1,728. So 1,728 times x cubed would give us the volume of a box in cubic inches. All right, the last one we have, so we're going to replace, every time we see an x, we're going to replace it with x plus 1. So there in the end, we would have x plus 1 minus 1. Okay, so when you put x in there, where we already had x minus 1, if we replace x with x plus 1, we'd have x plus 1 minus 1, which 1 minus 1 would be 0. So in the end, we just have x. Now we'd multiply those together. So I'm going to do it from left to right. So I'm going to take x plus 1 times x plus 1. If I do that, I get x squared plus 2x plus 1. Again, you could use the box method. You could have FOILed either way. If you don't know how to do that, look back at your notes or make sure you talk to your teacher. But you should know how to do that. Okay, so then the last step, we have x squared plus 2x plus 1. Now we have to multiply everything by x. Now we're going to distribute the x through into the parentheses. So we'd have x cubed plus 2x squared plus x, or 1x. And that would be your final answer. So hopefully you did both of those right. Here at the end now, here we have a summary of what was talked about in this unit. Okay, in this last chapter, or section rather. So we talked about even functions and odd functions. So I would make sure you have that in your notes. Remember, if you're having like a summary sheet for every section, this is what's highlighted there would be what you should have in this section. Some of the rest of that is just tying together what we did in previous sections to talk about the end behavior and translating graphs. But otherwise, what's highlighted there in yellow is the new material that was covered in yesterday's video. So good luck now as you will be working on your assignment.